Jack, are you around here, Jack Aitchison?
I am. Hey, Sean.
Hey, Jack. So I'm going to give you your introduction here. Hey, buddy. Jack Aitchison is an energy engineering manager at the Association for Energy Affordability in Emeryville, California. Jack has provided engineering and technical support for various comprehensive energy efficiency and decarbonization retrofits of existing multifamily buildings. Additionally, Jack is an implementer of energy efficiency multifamily rebate programs in California, including the BAMBE that we learned about from Ben earlier, the Tri-County Regional Energy Network Multifamily Energy Efficiency Program, that's long, and California Tech Initiative, and the Low-Income Weatherization Program. So deeply experienced in California decarbonization programs. Thank you, Jack, for joining us.
Awesome. Thank you, Sean. And yeah, I just want to, before I start, just want to say I super appreciate you inviting me to speak. And it's been awesome to see how this forum has grown. I started at Redwood Energy as an intern 6 years ago and attended my first zero carbon retreat then, and it's just so awesome to be back and be presenting on a pretty admittedly scary topic. So I'll be presenting on the dangers of gas appliances in multifamily buildings. I'm with the Association for Energy Affordability. And a little bit of background. Can everyone see my screen? Just want to make sure.
Yeah, perfect.
Okay, cool. So a little bit of background on AEA. We are a nonprofit consulting firm. We specialize in energy efficiency and electrification of existing multifamily buildings in California and the state of New York. Some of our offerings are technical services, research and development. We do trainings on multifamily electrification and energy efficiency retrofits, and we also do some policy work. But surrounded, or I guess centered in all of that work, is the rebate programs and incentive programs that we incentivize. That we administer. And so here is a list of all of the programs that we administer throughout California. Primarily, they are existing building programs. We have a few new construction, but all of these programs offer money for electrification for multifamily buildings, market rate, and low-income properties. And so if you're looking to electrify your multifamily building in California, I can almost guarantee that there's a program that you'd be eligible for to receive money for that electrification work. Now, tied into our programs, we often require or implement a combustion safety testing protocol. So if a property enrolls in our building, if a property enrolls in our programs, we complete combustion safety testing throughout the property, and that typically goes as we'll enter a sample of dwelling units, typically around 10%. We will test all of the combustion appliances. And when I say combustion appliances, I'm talking natural gas appliances. We will test all of the combustion appliances in the dwelling units. We'll also test all of the combustion appliances in the common areas. We follow the Building Performance Institute testing procedures, and we test for carbon monoxide levels in the combustion gases. So that is the exhaust gases that post-combustion, you have all of these gases that are venting out of the apartment unit, out of the HVAC unit, out of the water heating unit. We stick a probe in there and we check to see what the carbon monoxide levels are in those combustion gases. We also check for appliance draft. We also look at the pressure differential between the living envelope and the outside. I'll go into more detail on that. And then we also look for gas leaks and recalled gas flex lines. So the next slides are going to be just some examples of us doing these tests and some anecdotal stories I have from completing these tests. And then later on, I'll share some data that we have just from properties that we have completed this combustion safety testing. So testing for carbon monoxide, it requires a combustion analyzer. That combustion analyzer has a probe at the end of it that you stick in the exhaust flue of the appliance. The Building Performance Institute standard is less than 100 parts per million of undiluted carbon monoxide in water heaters and furnaces. And the BPI standard is less than 300 parts per million diluted carbon monoxide in ovens, or air-free carbon monoxide, I should say. Now, as you can see on the photo on the right, This is a test that was done in a low-income senior home in the Bay Area. And as you can see, that combustion analyzer on the picture on the right, we have about 100 times the allowable limit of carbon monoxide exhausting from that wall furnace. And so that, that can certainly turn into a pretty dangerous situation. Now, unfortunately, this was not the only unit that we saw at this property that had this issue. Almost every unit we went into had extremely high carbon monoxide levels coming from the wall furnaces. Now, fortunately, all of these wall furnaces were exhausting these carbon monoxide levels, or sorry, these carbon monoxide gases out of the unit. But if there was backdrafting, that sort of thing, it can become a really dangerous situation. And in addition, it being a senior home, a low-income senior home, that's an extremely vulnerable population that we really don't want. I mean, we don't want anyone exposed to this level of carbon monoxide, but we really don't want our seniors exposed to that as well. We also test for carbon monoxide in ovens, and that is the air-free carbon monoxide. So that's the number below. The threshold is 300 parts per million based off of the Building Performance Institute standards. And on the photo on the left, you can see that we have a probe sticking in the oven, measuring the carbon monoxide levels that oven is essentially producing. Now, neither of these are above the considered safety threshold, but I do want to point out that gas ovens do not have flues. So really, you are required to use, or in order to get these combustion gases out of your unit, you have to use a hood fan. Now, in multifamily buildings in California, and really multifamily buildings, I guess, across the US, you're very fortunate if you have a hood fan, and you are even more fortunate if that hood fan actually is ducted to the outside. So these are photos all from the same apartment building, and on the right is a photo of the hood fan that is in these apartment buildings, and that is just a recirculating hood fan. That is not ducted to the outside. So all of those combustion gases that are being created by the oven being on is going to be resulting in, it's not going to actually be vented out of the unit. It's going to essentially get blown back into your face. Now, while I was at this property, my ambient CO alarm was at 5 ppm throughout the entire time I was there. This photo on the left, that is the property manager's unit, and as you can see, they use their oven. There's a pizza there. They were telling me that when we first came to this property, they were having issues with their fish tank, not being able to get the pH levels correct, and I was reading constant low levels of carbon monoxide throughout the entire apartment building. Through our rebate program, actually BAMBE, we replaced all of the wall furnaces with packaged thermal heat pumps, and we removed that low ambient carbon monoxide levels in the unit, and the property manager was able to get his pH levels back to normal for his fish. And I can't imagine what the low level of carbon monoxide exposure was happening to the tenants, but I don't have any more information on that. Appliance draft and pressure differential in the living envelope. So naturally venting gas appliances, they have a flue here. If you're looking at the middle photo, that is the flue, and then a flue cap. Combustion occurs at the bottom of this water heater, and those flue gases travel up and then out through the flue out to the outside. Now, the flue cap is designed so that air from the unit mixes with those combustion gases and then flows out of the unit. And you can see a diagram on the right from the California Plumbing Code. I included that just because it can be really tricky designing these flues in order to properly vent out combustion gases from a dwelling unit or a water heater closet. And I find it funny, I use it as an example because when we're retrofitting existing gas water heaters, installing heat pump water heaters, we get a lot of concerns around the complication of venting for in-unit heat pump water heaters. Heat pump water heaters are going to draw heat from the surrounding air. In our multifamily buildings, we have really small closets, and so oftentimes we want to vent that closet in order to have enough makeup air for the heat pumps to operate properly. And I've gotten feedback from contractors that it's complicated. I just point them to the 4 pages on how to design a flue to properly vent a water heater, a gas water heater's combustion gases. So it's just funny that, you know, they're used to designing these flues for water heaters, but the venting for heat pump water heaters seems to be a sticking point for them. Now, in order to test draft, so making sure that all of those combustion gases are going up into the flue, you use a smoke pen, which is exactly what it sounds. It is a pen that smokes, and you stick it in the flue cap, and you see the direction that the smoke is traveling, whether it's coming back into your face. If it is, that you know that all of those combustion gases are not being vented out of the apartment, and they're coming back into the apartment. In addition, there is a pressure kind of dynamic that occurs in a dwelling unit that we also need to take into consideration, and that is the pressure differential in the living envelope compared to the outside. Now, our homes are negatively pressurized compared to the outside, and so what that means is air is trying to infiltrate into the unit. If you turn on all of your fans, your bathroom fans, and you have a ducted hood fan, you're going to be negatively pressurizing that unit. And what's going to happen is more air is going to try and infiltrate. And you have this great big hole of a flue that is essentially a pathway for air to travel into the unit. And if you have your fans on and you are using your water, you're using hot water, what can happen is your fans can negatively pressurize your unit, causing those combustion gases to vent not out of the unit, but into your living space. So that's why pressure differential is very important. So as you can imagine, if a unit is not drafting properly, and if there's high carbon monoxide, that can result in pretty scary situations. And so these are some examples where that has happened in properties while I've been completing this combustion safety testing. Now, the photo on the left says 127 parts per million. The photo on the right says 84 parts per million. These are 2 separate buildings where once I saw that the unit was backdrafting, I immediately turned off, these are both wall furnaces. I immediately turned off the furnace and kicked everyone out of the unit. This was only running after about 30 seconds to a minute. You can imagine that if someone were to call for heat, not have a carbon monoxide alarm in their unit, carbon monoxide alarms go off at 150 parts per million. They also go off if they've been reading 30 parts per million for a long period of time. And so you can imagine after 30 seconds, we're almost to 150. And you know, you wait a minute, you wait 2 minutes, that person using that heater could suffer some carbon monoxide poisoning. So that can result in a pretty scary situation. We also test for gas leaks. Pretty simple. You use a gas leak detector. You sniff around the gas line. If you do find a gas leak, you spray it with a bubble solution, and that's going to confirm whether or not that it was a false positive or a false negative. You can see when you do find a gas leak, there's a bubble that forms when you spray that bubble solution. And our gas leak detectors read in parts per million. They go up to 1,000. Our standard is that, you know, once it gets up above 1,000, there is a different metric that reads in lower explosion limit, LEL. And if it gets to 10% LEL, that is when we evacuate the dwelling unit and call the utility. Now, unfortunately, I've had to do that quite a bit. Not quite a bit, but it's happened. And so as you can see here, this is a property down in the Santa Barbara area where we found a gas leak on the main gas line to the community room, and we're reading at around 48% LEL. And then on the right, it's kind of a tough picture to see, but we're reading 58% LEL in a water heater closet adjacent to dwelling units. So even though there are partition walls between the water heater closet and the dwelling unit, I can't imagine that there wasn't small amounts of methane leaking into the dwelling units from these gas lines, especially at that rate. I mean, you can see the alarm going off. That thing is telling me to get out of that closet. Then recalled gas flex lines. This is pretty telling on the deferred maintenance. We'll see some data on some properties that we visited, but recalled gas lines are really common in multifamily buildings. And they were recalled back in 1973. The standard now is steel flex lines, but we still see them all the time. They're prone to gas leaks. And it just goes to show that I don't know if it's an education thing, that maintenance staff just doesn't know that these are recalled. But you'd imagine it's 50 years ago, they have to have had many HVAC swap outs. And so maybe the HVAC contractor isn't aware of it, but it's pretty telling how, the level of deferred maintenance that can happen in multifamily apartment buildings. Oh, now I'm going to get into some combustion appliance failure data. I do want to preface this that this is not research grade data. This is data that I've collected from my colleagues, from projects that I've worked on over the last 5 years that I've been at the Association for Energy Affordability. And essentially we took that data, we did some data analysis, and that's what I'll be presenting today. Again, it is not research data. These are projects that enrolled in our energy efficiency and electrification programs, and we implemented combustion safety testing. So the data that I'll be presenting on is data from 1,209 dwelling units. We tested 1,812 combustion appliances. We categorized the issues between dangerous and preventative. What we're calling dangerous are gas leaks, drafting issues when there are no fans on in the unit. So that's that, we're not inducing negative pressure in the unit. That is just normal case. Anytime the water heater, the furnace turns on, it is backdrafting into the unit, regardless of what the tenant is doing. We also have high CO levels, and that is 100 ppm for furnaces and DHW and above 300 ppm for ovens. And again, ovens, we read it in air-free CO, and for water heaters and furnaces, we read it in undiluted CO. Preventative, missing CO alarms, drafting issues when all the in-unit fans are on. So really that is when you're negatively pressurizing your unit. And that is the only time that you're having backdraft from your combustion appliances. And then also moderately high CO levels between 100 ppm and 300 ppm for ovens, and then recalled 1973 gas flex lines. Now, out of the 1,200 units we sampled, we found that 49% of them had some sort of combustion safety issue. That is a combination of both dangerous and preventative, and primarily a lot of those issues were recalled gas flex lines and missing CO alarms. But I'd argue even like 15–20% of those issues being dangerous is a pretty staggering number and pretty eye-opening. So the next few slides are going to be some more in-depth data on the system type: furnaces, ovens, domestic hot water heaters. And so starting off with furnaces, we split the category into wall furnaces and forced air furnaces. We tested 869 wall furnaces and 278 forced air furnaces. For the wall furnaces, 42% of them had some sort of failure, and 15% of the wall furnaces we tested had a failure considered dangerous. And the primary failure that we saw from wall furnaces was backdrafting. And that is, wall furnaces are notorious for backdrafting. Every time I go to a building and I see a wall furnace, and unfortunately they're super common in California, I get a little bit like, oh gosh, I have to test this. But however, even though 42% had some sort of failure, the primary failure that we saw was a recalled gas connector. On the forced air furnace side, about half had some sort of failure. 14% of forced air furnaces had a failure considered dangerous. And the primary failure we saw from those forced air furnaces were gas leaks. And my hypothesis here is that forced air furnaces are primarily in closets. And they're in small closets where tenants aren't opening those as often. So as you can smell the methane, if it's kind of isolated in that closet, you're not going to hear tenant complaints. Whereas with ovens and wall furnaces, it's out in the living envelope. If it's leaking gas and you can smell it, you're going to report it. Oven combustion safety data, we tested 147 ovens. 27% of those ovens had some sort of failure, and 4% of those ovens had a failure considered dangerous. About a quarter of the ovens that we tested had high CO levels, either between 100 parts per million and 300 parts per million, or above 300 parts per million. Now, as I mentioned before, the only way that these combustion gases are going to be leaving your apartment building in a from an oven is a hood fan. And again, you are lucky in California if you have a hood fan. You're even more lucky if you have a hood fan that is ducted, that is actually pulling those gases out of your unit rather than filtering them and recirculating them back into the unit. We also saw a few gas leaks as well on those ovens. So on to domestic hot water combustion safety data. We tested 231 central domestic hot water heaters. We tested 138 in-unit DHWs. And what we found were that the failures that we saw in domestic hot water heaters were less. We only saw 12% had some sort of failure and 9% had some sort of failure for central and in-unit respectively. However, it's disproportionately those failures were considered dangerous. Either backdrafting or gas leaks are really the primary things that we saw regarding gas water heaters. And so about 10%, let's see here, about 4% of central water heaters had a gas leak, and about 5% of in-unit water heaters had drafting issues. So combustion gases drafting back into either the water heater closet or the living envelope. This is the last piece of data that I'll share. This is just dwelling units with missing CO alarms. So this is the percentage of dwelling units that we tested that had appliances producing CO, and the correlation of whether or not they had a CO monitor present. So out of the 1,200 units we tested, 7.1% of them had a appliance inside of them that was producing high CO without a CO monitor present. And then about 4.1% of the units we tested had an appliance with high CO, and they also had a carbon monoxide alarm. So as you can imagine, without a carbon monoxide alarm, you really have no protection against these gas appliances and producing high CO, and then backdrafting that can cause a very dangerous situation. And we all know what can potentially happen if these issues go, if they don't get addressed, the issue can grow. It can result in significant injuries, gas explosions, carbon monoxide poisonings. And here's some snippets of some news articles around that. And then I also have a bunch of links to news articles. So again, even though the units that we went into, those dangerous issues were pretty moderate compared to these, then the number that we saw was fairly staggering. And if those go unchecked, what's going to happen is essentially what you're seeing on the screen here. So gas appliances have, they have real dangers to multifamily buildings, specifically because you have a combination of deferred maintenance and gas appliances. That's essentially how you end up in these situations. So what can we do? Well, there's really only one answer, and I'm sure a lot of folks on this call agree with me. That is Electrify. So just get rid of the gas in those buildings, switch to an all-electric building. We have some photos here of a furnace being converted to a inverter-driven mini split with an interior air handler. The photo on the bottom left is a wall furnace being converted to a mini split with the traditional kind of head unit, removing gas ovens and replacing them with induction stoves. And then the photo on the right, these are pretty cool photos. These are of a central heat pump water heater, a Mitsubishi low GWP central heat pump water heater going in to a multifamily building in the Tenderloin. It is a 120 unit building. And it was built in 1920 with pretty much all original piping and hot water distribution system. And if that building can electrify their water heating system, I can assure you it is possible in many other properties. Now that building took advantage of the incentive programs available to them. The cost of the work was around $650,000. The incentives were able to provide $500,000 And because of all of that, the property was able to upgrade their system and remove their primary gas user, which was their water heating system, and swap it to a heat pump water heater. And these units are really, really low energy compared to the consumption or compared to the capacity that they have. So we were able to fit them within the existing electrical service at the building. So super cool, super great example of how you can leverage different incentive programs to help make your electrification project feasible for your property. And then the last slide I have here is just circulating back to all of the different rebate programs that AEA administers. There are many others out there in California. These are just the ones that we're involved in. And I wanted to add that a lot of these programs, they do have a combustion safety testing procedure, but they also have a technical assistance aspect to them, which essentially means that you'll get someone like me, someone from AEA who has experience with electrifying existing multifamily buildings and kind of provides technical support to the contractor, to the engineers, to the building owner to make sure that these projects are done in the most cost efficient and most energy efficient and the most impactful way. So awesome. And then my contact is down here if anyone is interested in reaching out, asking questions about any of the programs that we administer. If you have a multifamily building you want to enroll in one of these programs, please reach out to me. I can help you get started on that.
Jack, you're amazing. So that was terrifying. You're absolutely right. That was scary. And I was wondering if you could scare people more and tell them about your own personal trip to the hospital.
Yeah. So the property, let's see here. This property here with the the ovens. So this project was a 40-unit building in Vallejo, and I was tasked to do combustion safety testing in all of the dwelling units at that property. And I had been there probably about 6 hours with low carbon monoxide ambient levels in the entire property the entire time I was there. And I was following all of the procedures that we do, but there was one oven in particular that I wasn't even able to get a reading on because I turned it on. I asked the resident if they've used their oven before. I turned it on. I walked away, which you shouldn't do, and I started to light the pilot light on the wall furnace. And as I was doing that, when you're doing combustion safety testing, you have a lot of equipment for different things that you're measuring, but all of that equipment has a carbon monoxide alarm. And when I was lighting that pilot light, I lit up like a Christmas tree. Everything started going off, and I started to walk over to the oven, just instinctually turned it off, kicked the resident out of the unit, and I did have to go get some oxygen after that. I felt pretty lightheaded after a long day of testing, and then just like a shock of a bunch of carbon monoxide. We called the utility. The utility came out, removed the oven. But unfortunately, we weren't able to electrify the ovens at this property. We electrified literally everything else, but unfortunately the ovens, they just have too much electricity capacity requirements to fit within the service. A service upgrade is a pretty, it can be a project killer at times, working with the utility, having to work on the utility's timeline. I have a project right now that we're undergoing a service upgrade, and it's been about 1.5 years waiting on the utility to let us know what we need to upgrade on our side to match what they're doing on their side. And so unfortunately at this property we weren't able to electrify the ovens, but they'll have to do it sometime. So at least there's that.
Yeah, when you had that near-death experience, I really wondered whether or not I'd set you off on the right career path. Am I somehow related to your parents losing their child? Oh no, so yeah, we're glad that you're safe, and I assume that you've heard about the newest 120-volt stoves that are coming out, and they're not available yet, but do you know, is AEA considering trying to deploy those stoves? You guys had a
Oh, absolutely. I have a project out in Larkspur in like Northern Bay Area, and we are looking to see if those 120 volt stoves will work out for the property. It's kind of it's a game of, you know, we can electrify the space. There's existing electric ovens at the property. We can't electrify the space heating with the current available capacity. So we're looking into installing those 120 volt electric ovens in the units to then free up enough capacity for the space heating and also the central water heating as well. So hopefully we're able to do that. We're leveraging a bunch of different incentive programs to push the property forward. A great one that wasn't included in the list because we're not implementing that program is Energy Smart Homes. Provides a lot of incentives, $3,550 per unit for all electric. That can go all the way up to $6,000 per unit if you do in-unit heat pump dryers, central heat pump water heating, all of that good stuff. And that can be layered with some of our other programs as well. So that you can really start to see, you know, 8,000 per dwelling unit in terms of incentives for doing this sort of work.
Thank you. Ted Tiffany wanted to make a point here that carbon monoxide home alarms are terrible by the design of the standard. At 70 ppm, the standard requires the sensor to trip after an hour at that level, and that's if it's in the right location. Do you want to respond to whether or not you feel like even the sensors are adequately protective?
Yeah, I completely agree. I think that you know, these even 100 to 300 ppm out of an oven is not considered dangerous. It's considered a recommendation to have the owner do some mitigation measures. And so I completely agree. I mean, I would prefer to have it go off at, you know, 5 ppm or 10 ppm. And it is funny that I have a personal CO alarm that, you know, you carry along with you on tests, on projects and that sort of thing. And it goes off at 5 ppm. And it's a little bit annoying. You'll be in traffic and it'll go off. You'll be sitting having lunch and there'll be a propane heater next to you and it'll be going off. But I completely agree that, you know, we need to have more, well, I mean, hopefully we don't need to have carbon monoxide alarms in the future because we'll be getting rid of our gas appliances, but it would still be a good idea to have them. But, you know, I completely agree that 30 ppm after 8 hours, that's when a carbon monoxide alarm will trigger. That doesn't seem sufficient to me. You know, seeing this in the field, I definitely think that the data that we have is quite staggering. And I think that, you know, the shift in what is considered a safe level of carbon monoxide has kind of like, that target has kind of shifted quite a bit. And so we actually use an old standard of the BPI threshold because it's a little bit more stringent than the newer version.
Well, thank you, Jack. I'm going to be transitioning to the next speaker who's going to talk about fossil fuel emissions from local wells. And it's just all the same topic of how poisoned people are being from fossil fuels in their lives and their homes. But I think that if you didn't scare people a little bit from that, then people aren't listening. Thank you so much, Jack.
Thank you for having me.
Thank you, Jack.